Hello students, this video is to assist with Unit 8 in the Common Core Algebra curriculum. The unit is on quadratic equations, and the first couple of lessons were about factoring and solving. So it's to solve each equation by factoring. The best way to learn about solving equations by factoring is to just do a lot of examples, and these two are the first examples that I wanted to do. Notice that these equations are already factored. They're already turned into two binomials that are multiplied together. So what we're going to do is we're going to factor them by using the method of splitting and solving. We know that when there are two different items that are being multiplied together that equal 0, one of them is going to have to be equal to 0. So on the left side, I'm going to take k plus 1 and say, well, what if k plus 1 was equal to 0? Wow, that is, font is way too big. Let's make it this size. Much better. Okay, so we're saying, well, what if k plus 1 was equal to 0? And we're also saying, well, what if k minus 5 is equal to 0? Change this font also. Once we get this set up, all we have to do is solve the equations, the easier equations, for the value of the variable. So in this case, we're going to subtract 1 from both sides, and we're going to get k is equal to -1. So that's one possible value. On this side, we said k minus 5 is equal to 0. We'll add 5 to both sides, and we will get k is equal to 0 plus 5, which is 5. So our two values, or two possible values, are k equals -1 and k equals 5. These values are called the roots, they're called the zeros, they're called the solutions. So these values are called roots. They're also called zeros. They're also called solutions. Ooh. And they can be written in several different ways. They can be written as equations. You can write it as this. K is equal to, curly bracket, -1 comma 5. That's one other way that you can write those roots, zeros, or solutions. And a final way that you can write them is saying -1 comma 0 and 5 comma 0. Usually we reserve this for when we're talking about x's, like if these were x values, but this is an acceptable way of expressing these answers. Alright, in this case we can do the same thing that we did before. We have a plus 1 and a plus 2 is equal to 0. We're multiplying them together, so we split it up like this, and we say, well, if this times this is equal to 0, one of them is going to have to be equal to 0. So we'll say, what if a plus 1 is equal to 0? And we'll also say, what if a plus 2 is equal to 0? Again, we're using that zero product property that we just talked about, so we call that the zero product property. When you're taking some term and you're multiplying it by some other term and it's equal to 0, we're saying that either a equals 0 or b equals 0. Let's see if I can find a more convenient place to put this, because this seems like we're mixing it in here. Okay, great. So we have a plus 1 is equal to 0. Let's solve this one. And we know that a plus 1 is equal to 0, so we'll subtract 1 from both sides here. And we'll get a is equal to -1. And likewise on the other side, we'll say, well, if a plus 2 is equal to 0, we'll subtract 2 from both sides. Keep doing that. It's so weird. That's 2. And we'll get a is equal to -2. So again, we can write this in the same exact way that we wrote all the other solutions on this side. Pause the video for 1 second and see if you can write it in the same exact way. Okay, let's see if you got it right. Here are your answers. You could have written it like this, or you could have written it like this. So these first two examples were fairly easy because they were already factored for you. So in the next couple of problems, we'll just take a look at what happens if it's not factored for you yet. On this one, we're sorry about that. We're going to go to the next one here where they're not factored yet. Okay, so you can see that the first one is not factored. It's x squared minus 11x plus 19 is equal to -5. It's not factored, and another problem is that it's not equal to 0. So in order to answer this equation, we have to set it so that it's equal to 0. So our first step should be to add 5 to both sides. If we add 5 here, it becomes 0. So here I've rewritten the equation. Now on both sides, I'm going to add 5. Add 5 over here. I'm going to add 5 over here. On the left-hand side, the 5 combines with the 19, and that should give us positive 24. So our left side is x squared minus 11x, and that's plus 24, and that's equal to 0. Now we have a quadratic equation which is equal to 0, which is what we wanted. Now we can use the zero product property, and all we have to do is factor this. In order to factor this, we're going to use the AM method. You remember AM method means, or stands for add and multiply. So we're going to find all the numbers that multiply together to give us 24. So what are the numbers that multiply together to give us 24? Well, we know that we have, as an example, like 6 and 4. We have 2 and 12. We have 1 and 24. But none of these are going to add together to give us a negative 11x. So we're going to have to change our perspective, and we're going to try to get some numbers that are negative. Let's try negative 3 and negative 8. Well, it turns out that negative 8 plus negative 3 is negative 11. So these are the ones that we're going to use. Now that we've identified our two numbers, what we're going to do with them is put them into two sets of parentheses. And those two sets of parentheses are going to look like this. We're going to start both parentheses with x. Because x times x is x squared, we need a minus 3 here. And in the set of second parentheses, we're going to put minus 8. And it doesn't matter which order you put them in. This could be x minus 8, and this could be x minus 3. Doesn't matter. Is equal to 0. Now we have our two factors. We can split it up and say, well, both of them are possibly equal to 0. So rewriting it, we'll get x minus 3 is equal to 0. That's on the left-hand side. And on the right-hand side, we'll get x minus 8 is equal to 0. And we'll solve both equations just the same way we solve any other equation using the 5 golden rules, 4 of which you know. We'll add 3 to both sides. And we'll get x is equal to 3. And on the right-hand side, we'll add 8 to both sides. So plus 8 plus 8. And we'll get x is equal to 8. And we can express it as a solution set. X is equal to 3 and 8. And we can also express it as 2 points. So 3 comma 0 and 8 comma 0. On the other side, we have a similar dilemma that we had on this side. It's not equal to 0 yet, so all we're going to have to do is set it equal to 0. And you can see I've rewritten the equation here. N squared plus 7n plus 15 is equal to 5. In order to solve this for 0, we're going to subtract 5 from both sides. So 5 minus 5 on the right-hand side is going to give us 0. And on the left-hand side, we'll just have n squared plus 7n. This is exactly the same. But 15 minus 5, that's going to give us plus 10. And I said that it was going to be equal to 0. We're going to use the AM method again for this side. So we'll put a little dividing line here so we don't mix everything up. And the AM method means we're trying to find the numbers that multiply together to give us 10 and add to give us 7. So we take our 10 out here, and we make a little T-chart for it. And in the T-chart, we're looking for all the numbers that multiply to 10. And hopefully one of them is going to add to 7. Oops, messed up that line. That's crooked lines for you. So the first pair, I guess we could use 5 and 2. And hey, look at that. We don't have to find any other pairs because 5 plus 2 is equal to 7. 5 times 2 is equal to 10. It's almost as if I've done this problem before 100 times. We know that n goes in the parentheses first because n times n is n squared. N plus 5 and n plus 2 is equal to 0. So now we've factored it. We're going to use the same method of split and solve. We'll split it into two different pieces, and we'll say, well, what if this side was 0? We'll say n plus 5 is equal to 0. We subtract 5 from both sides, and we get n is equal to negative 5. Now on the other side, we'll do the same thing. We have n, well, lowercase n, pal, plus 2 is equal to 0. We'll subtract 2 from both sides, and we'll get n is equal to -2. And we can write it as a solution set. We could, I guess technically we could write it as points, but this is going to be sufficient for your answer. So these ones were fairly easy to factor because we were able to use that AM method, but sometimes we won't be able to do that. For example, in this case, we can't use AM method because the coefficient of x squared, or in this case n squared, is not 1. We have a 6 in front of here. So there are a couple things we could do here, but the first thing we're going to do is try to solve it for 0. So we're going to try to move that 6 to the other side. Alright, so I rewrote the problem. The first thing we're going to do is set this equal to 0. So we'll subtract 6 from both sides. And we'll get 6n squared plus 18n. This doesn't change because those are not like terms with -6. But 18, which is negative, minus 6, that's -24. And that should be equal to 0. Now you might think to yourself, well, we can't use our factoring method, a and m, because we have an a value that is greater than 1. Well, the first thing we're going to try to do is see if we can factor it anywhere else, and it looks like we can do GCF here just fine. The greatest common factor of all of these terms, 6n squared, -18n, and -24, we know our GCF is going to be 6. So I'm going to rewrite this problem as a factored problem. The 6 is going to go on the outside of a set of parentheses, and we know that the n squared is going to go inside. That's my leftover. I also know that 6 times -3n is going to give us -18n, and 6 times -4 is going to give us -24. So I factored it once. I factored it using GCF. The next type of factoring I can use is AM. Now I can use AM because n squared does not have a coefficient. So my next step is to write the 6, and I need 2 sets of parentheses. I just don't know what to put inside of them just yet. I can put an n here, n goes here, and n goes here. So we're going to need to determine the numbers to put inside of these parentheses, and we'll take the -4 out here, and we'll make a t-chart of all the numbers that multiply together to give us -4. Well, in this case, we're going to have to keep track of our positives and negatives. So the first one, it could be, -4 and +1. It could also be -1 and +4. It could be -2 and 2. It could be, well, I guess 2 and -2, which is the same thing. The only ones that add together to give us -3 are -4 and 1. So those are the numbers I'm going to use. I'm going to put a -4 here. Pardon my weird spacing. And then +1. And we know that whole thing is going to be equal to 0. And now, when we factor, we have to remember one thing. The only reason we factor this way, the only reason we're splitting this up and saying, well, one of them could be 0 and one of them could be 0, is because this has a variable in it. The n-4 has a variable in it. So that variable could be anything. So it's possible for this term to turn into 0. It's also possible for this term to turn into 0. The important thing to remember is that the 6 cannot turn into a 0. The 6 is a constant. So when I split it up, I'm only doing ones with variables inside of them. So I can say n-4 could be equal to 0. I could say, similarly, that n plus 1 could be equal to 0. But I can't say that 6 could be equal to 0. That doesn't make any sense. So I'm going to solve both sides. I'll add 4 to this side. I'll add 4 to this side. And I'll get n could be equal to 4. It's a possibility. Same thing here. I'm going to say -1. Whoa. -1 and -1. So I'll get n is equal to -1. So I have 2 different possibilities. Last but not least, I got an equation over here that has a 7 on the opposite side. I'm just going to solve this one without talking it through because my time limit is 15 minutes. So let me write it out for you. All right, see if you can follow along with this. I rewrote the equation. I moved the 7 over to the left side to make it equal to 0. I noticed that there was a common factor of 7, so I factored that out. Then I noticed I could use AM method to factor it. My last step is to set both of those equal to 0. But notice that they're the same equation, so my answer at the end is just going to be r equals 1. That means there's only one root. All right, hopefully this video was helpful. Stay tuned for my next video.